Hey guys, and welcome to this video on making real-world equations and domain and range. So, I hope you enjoy. Alright, so our first objective is to learn to create equations that will describe some real-life relationships. And here are some strategies that I have for creating equations to model these real-world situations. First, let's identify the two quantities we have, and we want to be really specific. It may not be good enough to just say years. You might want to say years since, 2000 or something, or hours since 9 a.m. or something like that. You're going to want to give each of your quantity, the independent quantity and the dependent quantity, a variable to represent it. You can use x to represent your independent quantity and y to represent your dependent quantity, or you can of course use whichever variables you'd like. Note, do not name your variable the first letter of the quantity it represents. It's a very, very tempting thing to do, but don't do it. It can be really confusing. Third, of course, decide which quantity variable is independent and dependent. Now, you don't have to do this fourth step, but I find it really helpful, which is to create a table of values for the two quantities, just using your intuition. And I find that making that table of values really helps with creating the equation to actually describe the relationship. And once you think you've created that equation, it's a great idea to just check it against the table of values that you made to make sure it's right. So let's go ahead and try some. First example, on January 16th, you signed up for Twitter, and of course you had 0 followers. Since then, at the end of each month, you check how many followers you have, and you end each month with 18 more followers. Great. Okay, I think our dependent quantity here is going to be the number of Twitter followers you have, and let's name that variable y for now. That's kind of our output, if you will. Our independent quantity is going to be the number of months since January 16th, and since that's kind of like our input, let's call that variable x. Okay, now it's time to make some ordered pairs for this relationship on that table of values on the right. So why don't you take a moment to do that, and then we'll reconvene. Now that we've got these ordered pairs, it's time to make our equation. I think our equation is going to be y equals 18x, or y equals 0 plus 18x. 0 representing how many Twitter followers you started with, none, and this 18 representing how many new Twitter followers you had at the end of every month. Note, very often when we're modeling real-world situations with equations, our equations will be in the form dependent variable equals whatever the equation may be. Very similar to when we were dealing with functions and we had output equals whatever it may be. Remember, independent and dependent variables can really also be thought of as inputs and outputs to functions. Now, the equation that we just came up with is a very powerful tool, as it tells us the relationship between the number of followers you have and how many months it's been since you signed up for Twitter on January 16th. Now, I claim that there are some input-output pairs that would work with the equation, but that don't make sense in real life. Can you think of any? Why don't you pause the video and try to think of some? For instance, the ordered pair -1, -18. That definitely works with our equation, but that would mean that 1 month before you signed up for Twitter, you had -18 followers? Or -2, -36. That ordered pair definitely works with the equation, but it obviously doesn't make sense to have a negative number of followers. To me, it seems that the only acceptable numbers of months you can have are 0, 1, 2, 3, 4, etc., etc., and the only possible numbers of Twitter followers you can have at the end of the month are multiples of 18 that aren't negative. And this brings us to a very important definition about what are acceptable input and outputs for functions. Our first definition is the domain of a function. And here's the informal definition. The domain of a function is just all the acceptable inputs that that function can take in. The formal way of saying it is the domain of a function is the set of values for the independent variable for which the function is defined. So for this specific function, I think the domain is 0, 1, 2, 3, 4. And to show that it keeps going on, we would write a ... meaning it goes on in this way. Alright, let's define the range of a function. My informal definition is the range of a function is just all the possible outputs that a function can give out. The formal way of saying it is the set of values for the dependent variable for which the function is defined. For this specific function, All the possible outputs are 0, 18, 36, 54, etc., represented by this ... Okay, question. How would the equation, domain, and range for this function change if the number of Twitter followers we had every month increased by a different amount, say 12 each month, or 20 each month? Why don't you pause the video, try to come up with the new equations, domains, and ranges, then unpause the video and check your work. So if our Twitter followers increase by 12 each month, the equation would be y equals 12x, or what I like even better, y equals 0 plus 12x, 0 being the number of Twitter followers you started with, and 12 being how many more Twitter followers you had at the end of each month. The domain would not change at all, but the range would be 0, 12, 24, 36, all multiples of 12 going up. If they increased by 20 each month, the equation would be y equals 20 times x. Or again, what I prefer, y equals 0 plus 20x. 0 being the number of Twitter followers you started with, and 20 representing how many more Twitter followers you got every month. And the domain wouldn't change at all, and the range would be 0, 20, 40, 60, 80, all multiples of 20 that aren't negative. Alright, let's do another example. After being posted to YouTube on October 5th, having 0 views of course, a viral video received 10,000 more views each day. First things first, let's find our independent and dependent quantities. I think our dependent quantity is going to be the number of views this YouTube video has. And let's make that variable something random, d. Our independent quantity is going to be the number of days since October 5th. And let's give that a random variable, let's call it n. Alright, next, let's go ahead and make a table of values for this relationship. Alright, now that we have this table of values, I think we're ready to go ahead and make an equation. Why don't you pause the video and try to come up with the equation yourself, and then play it. Alright, I think the equation here is going to be d equals 10,000 times n, or d equals 0 plus 10,000 times n. 0 meaning how many views the viral video had when it was posted, and 10,000 being how many more views it got every day. I think the domain in this case, all of the values of our independent variable, or all the values of our input, is going to be 0, 1, 2, 3, etc. The range, all the values of our dependent variable, or all the values of our output, is going to be 0, 10,000, 20,000, 30,000, etc. One thing, when you're dealing with thousands, it can be really weird when you're listing it with commas. You got to be really careful about what commas are separating values and what commas are your kind of thousands marker for big numbers. I want to introduce another way we could have defined our variables, which would change our equation, domain, and range, but might make things a little easier for us. What if we defined our dependent quantity to be the number of views for this YouTube video, but in thousands? Since we've changed the definition of this quantity, we're going to have to change its variable as well. So let's come up with a new variable, a random one. How about r? Let's keep our independent quantity the same. It's still the number of days since October 5th. That's going to remain the same variable, n. Now we're going to have a slightly different table of values for this relationship. Why don't you pause the video and try to make a new table of values for this new definition of our dependent quantity. Okay, now that we've got a table of values, let's go ahead and try to make an equation. Why don't you pause the video and try to make the equation. Okay, note that with our new definition and our new table of values, our equation becomes r equals 10 times n, or even better, r equals 0 plus 10 times n. 0 representing the number of views we had on the first day, October 5th, and 10 representing 10,000, which is how many more views that video got every day. Our domain remains exactly the same because we haven't changed how we define our independent quantity, but our range will change. Our range in this case is going to be 0, 10, 20, 30, 40 instead of 10,000, 20,000, 30,000, etc. Alright, let's try a few more. On February 7th, you purchased a new car with 0 miles on the odometer. Since then, you drive it consistently throughout each month, and you put on 2,000 more miles over the course of each month. Why don't you pause the video and you come up with the dependent and independent quantities and give them both variable names, create a table of values, and create an equation, and then we'll reconvene to talk about the domain and range. In this case, our dependent quantity is going to be how many miles are on the car, and let's give that a random variable. How about Q? And our independent quantity is going to be the number of months since February 7th, and we'll give that another random variable. Let's call it G. Here's a table of values to describe that relationship, and in this case, the equation would be Q equals 0 plus 2,000 times G. 0 being how many miles the car started with, and 2,000 being how many additional miles get put on the car every month. Note that if you were to graph this relationship, and here's a quick sketch of what I think that graph would look like, I think that graph would be continuous, because throughout the entire month, you are constantly driving that car. Maybe a few miles here, maybe a few miles there, but of course, the car can't get to 2,000 miles without hitting every single mile marker before that, even down to the 10th of a mile, 100th of a mile, 1,000th of a mile. So a continuous graph would best capture this relationship, and that means our domain and range are going to be slightly different than they were before. Our domain in this case, all of our possible inputs, all of the possibilities for how many months it's been, is no longer going to be 0, 1, 2, 3. It's just going to be any non-negative number. So what I like to do in this case is actually use an inequality to write that. And we're going to write G is greater than or equal to 0. This means the number of months can be any number, a fractional amount of months, a decimal amount of months, as long as it's a non-negative number. Our range in this case is not just going to be 0, 2,000, 4,000, 6,000. It's going to be any number of miles as long as it's not negative. So once again, we're going to use an inequality to show this, and we'll write Q is greater than or equal to 0, meaning you can have any non-negative mile amount. Note, not all the time, but often when we're modeling real-world situations, both the domain and the range of our functions will be all non-negative real numbers. Just because there's a lot of stuff in the real world that can't be negative, like a negative distance, sometimes negative time. Oftentimes, our domain and range are just going to be all non-negative numbers. Okay, let's try another one. On January 11th, you started your retirement savings account with $0 in it. Since then, you have exactly $350 taken out of your paycheck at the end of each month and have it deposited directly into your savings account. So why don't you pause the video again, and I'd like you to find the dependent quantity, independent quantity, give them variables, create a table, create an equation, and find the domain and range all on your own, and then play the video, and we'll see how it went.